Nernst equation, right? In the previous class, we have discussed about electrode potential. What is electrode potential? Here, dear students, my small suggestion is you have to be perfect with the meaning of the concept and what is the meant by the different scientific terms here. What is electrode potential? Electrode potential ante enti? What is electrode potential? So just I'll briefly explain you, and that I already explained you in the previous class. Suppose if you take any beaker like this and you take some solution into this beaker, say for example zinc sulfate solution. Zinc sulfate solution is taken in this beaker and zinc metal rod is kept in the solution. This is zinc metal rod. Zinc metal rod consists of a large number of zinc atoms. Zinc sulfate solution consists of a large number of Zn+2 ions and SO4 ions. Here if you can observe, these zinc atoms are in contact with zinc sulfate solution. When zinc atoms and zinc sulfate solution, that means zinc ions, these two are atoms and ions are getting in touch here. Both are in contact. When metal atoms are in contact with metal ions, there exists some potential difference between metal atoms of zinc, that is metal atoms of zinc metal and zinc ions of the solution. When these two are in contact, there exists some potential difference. This potential difference is called electrode potential. That is the meaning of electrode potential. Now suppose if the concentration of the solution is 1 molar, concentration of the solution, zinc sulfate solution, it is also called electrolyte. Concentration of this electrolytic solution is 1 molar and temperature is at around 298 Kelvin temperature, that is a room temperature, and pressure is 1 atmosphere or 1 bar pressure. Under these conditions, see what are the conditions? Concentration of the solution is 1 molar, molarity is 1 and temperature is 298 Kelvin and pressure is 1 bar. Under such conditions, this electrode potential is also called standard electrode potential. Standard electrode potential. Electrode potential is represented by the symbol E. Standard electrode potential is represented by the symbol E naught. So dear students, you must understand what is the difference between the symbol E and the symbol E naught. E for electrode potential, E naught for standard electrode potential. What is the difference between electrode potential and standard electrode potential? Electrode potential means at any temperature. Electrode potential is at any temperature and at any pressure. Any temperature or any pressure. But standard electrode potential is the temperature is 298 Kelvin and the pressure is 1 bar pressure. And also the molar concentration of the electrolytic solution. What should be the concentration of the solution? Concentration of the solution must be 1 molar. Under these conditions, it is called standard electrode potential. It is represented by E naught. Okay. And in the previous class, we have discussed how to determine electrode potential of the cell, that is EMF of the cell and all. Those formulas and all we discussed. If you have not attended the last class, you please watch the previous video that I have already uploaded in our YouTube channel, and this class also is being recorded. And if any one of your friend missing this class means they can watch later. This is about electrode potential. I got electrode potential means it is the potential difference occurred between the due to the contact of metal atoms and its metal ions. Whatever the metal ions means similar type of metal ions, then we can say it's a corresponding electrode potential. If you take copper metal atoms are in contact with copper ions, then there exists some potential difference. It is called electrode potential of copper. Similarly, if you take any other atom like suppose let's take magnesium. Magnesium is in contact with magnesium ions. Okay, then there exists some potential difference. It is called electrode potential of magnesium. Okay, but here one small thing we have to remember is, while discussing about electrode potentials, we always discuss about reduction potential. We always discuss about reduction potential. What is the meaning of reduction potential? It is due to the process of reduction. What is the meaning of reduction? Reduction means gain of electrons. Gain of electrons, or decrease in the oxidation state. And my suggestion is, my strong suggestion all of you is, take a notebook and note down all these points so that you will get a complete notes of these classes. Otherwise, if you are simply listening the class and you cannot understand my class and any other class, you get the notes of this and write down the notes and try to understand the concepts. See, reduction means what? Reduction means gain of electrons. So I will give you one small example here. Now, Zn plus 2 plus 2 electrons gives, see, this is zinc ions, these are zinc ions, gains 2 electrons. Here oxidation state of zinc is plus 2 and gaining 2 electrons. Gaining 2 electrons. This plus 2 and minus 2 get cancelled and it becomes zinc. Zinc. This process is called reduction. This is called reduction. Here gaining of electron is taking place. And one more point you can observe here. Zinc oxidation state, here Zn plus 2. Here zinc oxidation state is 0. Nothing is there over 0, zinc here 0. Oxidation state decreases from plus 2 to 0. This is called reduction. Okay, I hope you understood the reduction process. And to make you understand the reduction, one more example I'll take, and you try to write yourself. Can you write the reduction reaction of copper plus 2, Cu plus 2 reduction reaction? Cu plus 2 gains 2 electrons. Reduction means what? Reduction means gain of electrons. Cu plus 2 gain of 2 electrons gives Cu. This is a reduction process. Here oxidation number reduced from plus 2 to 0 by the gaining of 2 electrons. So this is a reduction process. Here we are going to discuss completely about reduction itself. So we have to understand what is the meaning of reduction and how reduction process takes place and all. Right? Now let's come to the our main topic, Nernst equation. What is Nernst equation? This is the definition of Nernst equation. If you want, you can note down this definition. The equation which represents the dependence of single electrode potential on the concentration of electrolytic solution and temperature is called Nernst equation. Okay, and here I will make this definition simple for you. What is Nernst equation? Once again, I am going to read this. The equation which represents the dependence of single electrode potential means dependence of electrode potential on concentration of electrolytic solution and temperature. Right? and I'll come back to the previous screen. See here, on the beginning, I have explained you. See this? Here, this is the picture I have taken. So here, this metal rods are in contact with, metal rod is in contact with its solution. Now concentration is taken as 1 molar. Okay, if I change this concentration 1 molar, then the potential difference also changes. This potential difference also changes. If I change this concentration, potential difference also changes. Similarly, if I change the temperature, what I said, and here I have explained you about standard electrode potential. Standard electrode potential means electrode potential at the temperature 298 Kelvin. If you change the temperature, then this potential difference changes. That means the potential difference or electrode potential. Electrode potential of a cell, electrode potential of a cell depends on two factors. What are those factors? One is the concentration of the solution and another one is temperature. Temperature of the electrolyte, temperature of the cell in which this process is taking place. Getting the point? And Nernst equation, the definition can also be written as Nernst equation as an equation which gives the relationship between molar concentration of electrolytic solution and temperature. That's the Nernst equation. Dear students, please note down all these points one by one. And this is the Nernst equation. E is equal to E naught. E is equal to E naught minus RT by NF ln molar concentration of product by molar concentration of reactant. Note down fastly, note down. All of you note down, please. And see here, I'll make you understand what is the meaning of this representation. So here E for electrode potential at the given temperature. E for electrode potential of any at any temperature. E naught is what? E naught is standard electrode potential. Just I told you, no? Standard electrode potential means electrode potential at the temperature 298 Kelvin and the pressure is 1 bar and the concentration of the electrolytic solution is 1 m. And RT by NF, RT by NF, R means here the gas constant. Generally, we take it as gas constant, or T is absolute temperature. N is a number of electrons transferred during the process. N is number of electrons transferred. F is a Faraday. F is Faraday, that we'll discuss later in our classes. And Ln for natural logarithm. Ln for natural logarithm. Ln ln and product concentration by reactant concentration. All of you must remember this equation because this we are going to use many times in our coming discussion in this class. Please note down. Next, here single electrode potential are two types. Single electrode potential. So single electrode potential means in the previous classes I explained you about galvanic cell, no? Here in galvanic cell, see the galvanic cell, two half cells we take. This is zinc sulfate solution and this one is copper sulfate solution. For example, here zinc rod is kept, here copper rod is kept. Both are connected through external wire. There is a salt bridge. This is all discussion we had in the first class. If you have not attended the first class, please go to our YouTube channel. There you can find the explanation about this first class. This is the half cell. This first one is half cell. No need to worry. Just you keep on listening. Automatically you understand all these things. This is half cell. This one is half cell. This is half cell. Okay. So these both together called complete cell. This is a cell. This one is half cell. This one is half cell. So the combination of these two is called complete cell, right? And remember, so here we are discussing about single electrode means half cell electrode. Okay. Now, Sorry, 1 second. Okay, I hope you are following the notes also. Next, continue. Let's continue. Metallic electrodes and non-metallic electrodes. There are two types of electrodes. They are metallic and non-metallic. Now first we'll discuss about half cell reaction of chemical reaction of metallic electrode. Note down metallic electrode. Here note down this reaction. M plus n electrons gives M. So what is this? Note down, please note down. And I'm going to write once again. So what is this? M plus n electrons gives M. Now to make you understand this, I will take the previous example. Zn plus 2 plus 2 electrons gives Zn. Now you might have understood. So here M plus n means M for metal. M for metal. Plus n means it's an ionic state. Plus M plus n. Zn plus 2. Here in the place of metal, which metal I have taken? Just to make you understand this, I have taken one example. Zinc metal. What is the oxidation state? Plus 2. Here plus N. How many electrons I have added to cancel this positive charge? 2 electrons. Here how many electrons I have added? N electrons. So this is nothing but this is a reduction reaction. General representation of reduction reaction. And this is a reduction process. And similar to this reduction process. So M plus N, this is a metal ion gaining N electrons, becoming a metal. So it's a reduction process, right? This is a reduction reaction. Now come to the reaction. The electrode potential at any concentration measured with respect to SHE. SHE means standard hydrogen electrode that we discussed in the previous class, last class. That also is there in our YouTube channel. You can go and check the previous video and you will get it, all these points. Now, how to write this equation? See, all of you note down, please. E m plus n bar m. E m plus n bar m is equal to E naught m plus n bar m minus RT by NF ln molar concentration of M by molar concentration of M plus N. I hope you have written the previous reaction. So what is that previous reaction? Here, what is this M? This M is concentration of product. This is the product. These are the reactants. Product concentration by reactant concentration. Product concentration by reactant. What is the product? M is the product. And M plus N is the reactant. Okay. But what is M here? M is nothing but metal. Metal. For metals, the concentration is 1. Metallic for metals, the molar concentration is taken as 1. 1 second. But concentration of solids is taken unity. Unity means 1. Then how can we change this reaction? That this representation E m plus n bar m is equal to E naught m plus n bar m minus RT by NF ln. This becomes 1. Then this representation modified as RT by NF ln 1 by molar concentration of M plus N ion. M bar plus N. So note down this. Note down this. Next. RT by NF by, see here, what I have done, one small change. What is the difference between these two? This 1 by M plus N have written as M plus N. That means this from the denominator, it is taken into the numerator. When we take into the numerator, this complete form becomes reverse. This minus becomes plus. Here this is 1 by M plus N. This is just M plus N. You might have studied in logarithms. Okay. Now here this is a minus and the symbol changes plus. So note down this reaction. This is a final formula and this is very important. This final formula is This final formula is very important and all of you note down. Right? Now let's modify this formula again for metallic electrode. I hope you have written all the formula. E is equal to E naught plus what was there here? RT NF, RT by NF. R value in the place of R value is 8.314 joule per mole per Kelvin. Temperature is taken as 298 Kelvin. And Faraday, 1 Faraday is equal to 96,500 coulombs. Okay. These are the values. Once again, I am going back. I hope you have written this formula. Here I am going to substitute R value, T value, F value. R value, T value, F value. If I substitute all these values, then I will get a new value, that is the simplified form. R value is 8.314, T is 298 Kelvin, F is 96,500 coulombs. If I substitute these values, what I am going to get finally, this is the final formula. All of you note down please. E is equal to E naught plus 0.0591 by N. What is this 0.0591? This is nothing but this is the value of RT by F. RT by F. Okay, in the place of R into T, R value 8.314 into 298 divided by 96,500. If you do all these things, you will get 0.059 by N. Log C. What is log C? In the place of one second. Once again, I am going to write here E is equal to E naught plus RT by NF ln molar concentration of M plus N. This is the formula you have written. Now I am going to modify this. E is equal to E naught plus, here R value is 8.314 joule per mole per Kelvin and temperature is 298 Kelvin. F value is 96,500 coulombs. If I substitute all these values, we will get a 0.059. Okay. So here in the place of RT by F, what is the value of this one? RT by F, this value is 0.059 by, here N is there, N, write down that N, ln, in the place of molar concentration of M plus N, I am going to write C. C for concentration of the ions. That's all. This is the simplest formula and all of you should remember this formula. E is equal to E naught plus 0.059 by N ln C. One second. Okay. Log C. So write down this formula. Okay, next, let's continue. For non-metallic electrodes, just now whatever the formula we have seen, it is for metallic electrodes. What about non-metallic electrodes? Non-metallic electrodes like hydrogen electrode, chlorine electrode, fluorine electrode. What about for non-metals or gases? So now we see similar formula we get, but little bit difference. So here I have taken X. Here X is gas. In the previous example, I have taken metal M, but here X. And to this X, we are adding n number of electrons. Adding electrons is called reduction, no? So it is undergoing reduction. When n electrons is added to X, it becomes X minus n. We are adding n electrons, then it becomes X minus n. Okay. Now the electrode potential formula for this one is, and very similar to the previous one here, but one small difference. So what, how to write Nernst equation? This Nernst equation is written like this: electrode potential is equal to standard electrode potential. E naught means standard electrode potential minus RT by NF. RT by NF ln concentration of the product by reactant. Concentration of product is x n minus, x power n minus, and divided by x. X n minus concentration of x n minus by x. So in the previous representation, in the case of metals, how we do? How we did? So here, in the place of x, we have taken m, metal. Okay. Let's see. Here the concentration of x is taken as 1. Concentration of x is taken, non-metals, liquids, solids, liquids, gases is taken as 1 bar. It is taken as 1. Then this formula, this Nernst equation become modified to E is equal to E naught minus RT by NF ln x n minus. Right? This is the formula. By substituting the values, R value, T value, F value, and in the place of xn, x power n minus, if you substitute C, then this equation changes to, I'll come to final equation, 1 second. This equation changes to E is equal to E naught minus 0.0591 by n log x power n minus. So this is the final formula. Okay. Okay, dear students, till now whatever I have explained, if you would have understood, okay, it is good. If you have not understood this, then at least you try to remember two formulas, whatever I am going to give to you. For metals, electrode potential is equal to standard electrode potential plus 0.0591. If you want, you can write, otherwise no need, by n log C. For non-metals, all of you note down these two formulas. These two final formulas are important. Electrode potential is equal to E naught, minus 0.0591 by n log x, or log x power minus 1 concentration. So try to remember these two formulas. Among these two, this one for metals is very important, because in most of the cases we are going to get problems or questions based on metallic electrodes. And if you can remember the metallic electrodes, non-metallic electrodes can also be easily remembered. Just here plus is there, here minus, here plus symbol, here minus symbol, that's all. And here the concentration, everything is same. Okay. And we have left with some less than 10 minutes of time. Okay, here one small question to you. Electrode potential depends on. You try to answer. Electrode potential depends on. What is Nernst equation? Nernst equation tells about the relationship between electrode potential with concentration of the electrolytic solution and temperature. So electrode potential depends on concentration of the electrolytic solution as well as temperature. So both A and B, both are the correct answers. Next, the next equation for standard reduction potential of non-metal A. In the previous discussion, just 5 minutes back, the previous one, in the place of non-metal, we have taken X when A minus N is taken as C. What is the formula? You please tell me the formula for non-metallic electrodes. Nernst equation for non-metallic electrodes. E is equal to E naught. E is equal to E naught. For non-metals. For metals, E is equal to E naught plus 0.059 by N log C. For non-metals, E is equal to E naught minus 0.059 by N log C. Okay. The second option is correct. Represent the cell in which the following reaction takes place. This is the reaction given. You have to write its cell representation. Okay, really it is a little bit challenging question for you. Suppose if you have understood, it's okay. I will give you a small tip. What you should do here? మీరేం చేయాలి ఇక్కడ దీని రిప్రజెంటేషన్ రాయాలి రిప్రజెంటేషన్. సో హియర్ యూ forget about Ag and Mg because this is a solid. For solids, molar concentration is 1. This magnesium is also solid. Here the concentration is 1. And forget about these two. Next, what you have to do? Product concentration by reactant concentration. This is the product, this is reactant. That's all. If you can identify product and reactant, you can easily answer. Let's see. Calculate the EMF of the cell if E naught is equal to 3.17. First, what is the cell representation? What is the formula? E cell is equal to cell potential minus 0.0591 by N log product concentration by reactant concentration. Product concentration, what is the product? What is the product there? So what is the product? Mg plus 2. What's this concentration? 0.0001 by reactant concentration 0.0001. Okay, but it is 2 mg. 2 mg is there. There we should be very careful. Okay, you no need to worry. If you have not understood this, no need to worry. Later we will discuss many such problems. Then you can understand. So E is equal to E naught cell minus 0.059 by N log product concentration by reactant concentration. So product concentration is this Mg concentration and the reactant concentration is 0.001. Here square is there. Why is square? There in the given reaction 2 Mg was there, no? So in the place, so we have taken to the Ag power 2. So E naught cell is also given in the question 3.17 cell standard electrode potential of the cell. So on substituting all these values, we'll get the answer. Actually, see here, why we have written 2 in the place of N? Why we have written 2? What is N? N is number of electrons, no? So here how many electrons are transferred? See here, magnesium. Mg becomes Mg plus 2. Mg becomes Mg plus 2. That means 2 electrons are lost. 2Ag plus becomes 2Ag. Means 2 electrons are gained. Means number of electrons transferred 2. So we have taken 2 in the place of N. Here N value 2. Okay. No need to worry. This is the first problem. Some of you may feel difficult in understanding. No problem. But if you just keep on listening, you surely understand. Now, Nernst equation, write down Nernst equation for cell. Dear students, this class will be ended in 3 minutes, within 3 minutes. If the class is ended, you please rejoin once again, just for 10 to 15 minutes, that's all, for this class. And I will stop the class. If the class is ended after 3 minutes, you rejoin the class. Again, we will discuss just one more topic is there and small topic, continuation to this. And by this, I will end the class. Now, Nernst equation for cell. Now, complete cell. Nernst equation for complete cell. So, this is the formula we already know. Once again, note down Nernst equation for cell. Please note down electrode potential of cell. All of you pronounce whatever I am saying, you also say in your mind. So internally, E means electrode potential of cell is equal to standard. Here not for this 0 for standard electrode potential of cell. Electrode potential of cell is equal to standard electrode potential of cell minus 0.059 by N log product concentration by reactant concentration. This is the formula for total cell, for the total cell. This is a Nernst equation for the cell. What is total cell? Two half cells will be there, no? Anode and cathode. By combining these two, we'll get the total cell. For example, if this is a reaction, then how to write Nernst equation? A moles of A, B moles of B gives C moles of capital C and D moles of capital D. Here capital A, capital B are reactants. Capital C, capital D are the products. Small a, small b are number of moles. Number of moles of A, number of moles of B, number of moles of C, small d is the number of moles of D. For this, to write Nernst equation, you have to follow this last one. E is equal to E naught cell minus RT by NF ln concentration of molar concentration of the products divided by molar concentration of the reactants. What are the products here? Molar concentration of the product, this one. Okay, students, please rejoin the class. This class is going to be end now. Once again, you rejoin. See here, this form you have to remember. See here, this is the given equation. A moles of A plus B moles of B gives C moles of C and D moles of D. If any reaction given in this manner, then you have to write its Nernst equation like this. E is equal to E naught cell minus RT by NF ln molar concentration of the products divided by reactants. What are the products in the given reaction? C and D. Capital C power small c. See here, capital C whole power C and capital D power small d divided by capital A power A into capital B power B. Here small a, small b, small c, small d, these are the number of moles. They may be 1, 2, 3, 4 and whatever it may be. Okay, that means they may be some integer. Here since Q is equal to, okay, here in the previous one ln Q is taken. So Q is nothing but this one. It represents this part, molar concentration of the product to the reactant. Okay, next small one question is given here. This is one of the very important questions, and many times in different competitive exams we got this type of question. Okay, I see here. This is a very important question. If you want, you can take a screenshot of this. Standard potentials. Potential means reduction potential. Standard potential means standard reduction potential of some electrodes are as follows. Arrange the metals in increasing order of their reducing power. Arrange the metals in increasing order of reducing power. I will give you a small statement. You please note down in your notebook. Reducing power means reduction power. Reducing power. So here, what are these values? K plus bar K means plus becomes neutral. This is a reduction potential of potassium minus 2.93. Reduction potential of silver 0.80. Reduction potential of copper 0.34. Magnesium minus 2.37. And chromium minus 0.74. Iron minus 0.44 volts. Okay, these are the reduction potentials. So which one having the least value? Among these values, which is the least value? Least value is for potassium, minus 2.93 volts. This is the least value. When the reduction potential value is least or less, its reducing power is high. So reducing power is high. The reduction potential is low. Reducing power is high, more. Both are inversely proportional. So what we have to do here? Arrange these metals in the increasing order of their reducing power. Increasing order means lower to higher. Among these two, among all these, which one is having highest value? Highest value is for, see this one, 0 point plus 0.80, and its value is higher, so its reducing power is least. Getting my point, my dear students? Here value is, see, reduction potential is low means reducing power is high. You just note down this point in your notes first, then you try to answer. So potassium is having least value, least reduction potential. That means it will have highest reducing power. So among these one, and which one will have, the potassium should have highest. That means options C, 3 or 4. Among these two, any one should be correct. Next, which one is having highest value? Silver. Reduction potential highest means it have least reducing power, and it should be least. This 3 and 4 both are confusing. First metal and last metals are same, and you check other metals. After silver, next highest value. Second. After silver, next highest value. See here, copper. Positive value. Copper is having positive value, means copper. After silver, next one is copper. Okay, then only one option is there. Highest value silver, next higher value copper, next higher value iron. That means option C. Okay, now option C is the correct option for this. So note down this point. Lower the SRP value, higher is the reducing power. Note down this point. SRP means standard reduction potential value. Lower the standard reduction potential value, higher is the reduction power. Next, equilibrium constant from Nernst equation. This is the last topic, just 10 minutes, and we'll conclude the class. Equilibrium constant from Nernst equation. This is the Nernst equation. What is Nernst equation? Cell potential is equal to standard cell potential. Electrode potential of cell is equal to standard electrode potential minus 2.303 RT by NF log. You may confuse here. What is 2.303 log? Actually, earlier we have taken ln, no? LN ln. So to convert the ln into log, we have to use 2.303. 2.303 RT by NF log product concentration by reactant concentration. Say here mentioned, ln is equal to 2.303 log. Okay, I will just for 1 second. I'll try to understand. I will explain you. See, for example, if I have one value ln x, I want to convert this into log. To convert ln into log, we have to multiply with 2.303 log x. Now you understood what I have done here? In the place of ln, I have written 2.303 log. One more question to you. You please convert ln 10. Ln 10 is equal to what? In case of log, in terms of log, 2.303 log 10. That means ln can be converted to log by multiplying with 2.303. One more for your understandability. Ln 10 square is equal to 2.303 log 10 square. Okay, na? Similar to that, in the previous expressions, we have used ln here, ln. Okay, so this ln is converted to log by multiplying with 2.303. At equilibrium, see, we are considering the condition equilibrium. At equilibrium, what is the meaning of equilibrium? Equilibrium state. Okay, you might have studied in 11th class. Equilibrium state for reversible reactions. The rate of forward reaction is equal to rate of backward reaction. Such reactions are called equilibrium reactions. That state is called equilibrium state. At equilibrium, cell potential becomes zero. Very important point. At equilibrium, cell potential becomes zero. That means in this formula, this E cell becomes zero. This becomes zero. Then when this becomes zero, write down this formula once again in your notebook. Then this part becomes 0, then 0 is equal to E naught cell minus 2.303 RT by NF log this part product concentration by reactant concentration. Product concentration by reactant concentration is taken as Kc. Kc means equilibrium constant. Equilibrium constant. So in the place of this product by reactant concentration, I have written Kc. And E naught cell becomes, why E naught cell I have written? This becomes 0, no? E cell becomes 0 at equilibrium. Then this minus 2.303 RT by NF log Kc. This total part, if you send that side, left side, this minus part becomes plus. That means E naught cell is equal to 2.303 RT by NF log Kc. All of you note down this formula. Very important. Note down this formula. What is the standard electrode potential of the cell at equilibrium? Standard electrode potential of the cell at equilibrium. Standard electrode potential of the cell at equilibrium is equal to 2.303 RT by NF log Kc. And R value, T value, F value, you know. What are those values? R value is 8.314 joule per mole per Kelvin. Temperature 298 Kelvin. Faraday 96,500, approximately 500 coulombs. 96,500 coulombs. If you substitute R value, T value and F value, here R, T and F, then this formula becomes like this. That means this value becomes 0.059 by N. Now, okay. And this is the Nernst equation for equilibrium reactions. Right? 1 second. I'll go back. That's the equation. Okay, that's all, my dear students. And this class, I'll continue the class in the next tomorrow's class. And for today's class, you have to remember few points. The first point you have to remember is, what is Nernst equation? Nernst equation definition. It gives the relationship between what? Any one of you. Nernst equation gives the relationship between electrode potential with concentration of electrolyte and temperature. Next, Nernst equation for metals and non-metals, you have to remember. Nernst equation for metals, E is equal to E naught minus for metals plus 0.0591 by N log M plus N concentration. For non-metals, E is equal to E naught minus 0.0591 by N log Xn minus concentration. And total cell potential, E cell is equal to standard potential of the cell minus 0.0591 by N log product concentration by reactant concentration. For the total cell, this is for total cell. And Nernst equation at equilibrium, this is the last one. At equilibrium condition, E naught cell is equal to what? 0.0591 by N log C. So these are the points you have to remember. These are the points you have to remember. These are the main formulae. And for the coming class, for tomorrow's class, if you can recall these concepts once again, and if you attend tomorrow's class, and one or two problems we'll discuss, and we'll continue the next topic.